Bismillahirrahmanirrahim. A quote for today is by the Prophet Muhammad sallallahu alaihi wasallam, who said to be patient. Uh, Today the topic of my presentation is t-test, one sample with examples, strengths and weaknesses, and I am presenting it under the supervision of my professor Dr. Saira Afzal. Learning outlines of the presentation are introduction, requirements and assumptions of one sample t-test, how to format a one sample t-test, how to interpret results of one sample t-test, when to use this type of t-test, recent updates, and MCQs at the end. Learning outcomes are, at the end of this presentation, participants will be able to describe about introduction, requirements, and assumptions for a one sample t-test, how to format a one sample t-test, how to interpret results of one sample t-test along with uses and recent updates at the end. The one sample t-test, also referred to as a single sample t-test, is a statistical hypothesis test that is used to determine whether the mean calculated from a sample data collected from a single group is different from a designated value specified by the researcher. This designated value does not come from data itself, but it is an external value that is chosen for scientific reasons. Often, this designated value is a mean previously established in a population, a standard value of interest, or a mean calculated from other studies. Like all other hypothesis testing, the one sample t-test determines if there is enough evidence to reject the null hypothesis in favor of an alternate hypothesis. The null hypothesis for one sample t-test can be stated as that the population mean equals the specified mean value. However, the alternative hypothesis for one sample t-test can be stated as the population mean is different from the specified mean value. A one sample t-test compares the mean with the hypothetical value. In most cases, the hypothetical value comes from theory. For example, if you express your data as a percent of control, you can test whether the average differs significantly from 100. The hypothetical value can also come from previous data. For example, compare whether the mean systolic blood pressure differs from 135, that is a value determined in a previous study. How to explain that is the one sample t-test differs from most statistical hypothesis tests because it does not compare two separate groups or look at relationship between two variables. It is a straightforward comparison between data gathered on a single variable from one population and a specified value defined by the researcher. The one sample t-test can be used to look for a difference in only one direction from the standard value of one-tailed t-test, or can be used to look for a difference in either direction from the standard value, that is a two-tailed t-test. This Gaussian curve shows single sample t-test that it can go either way, that is in both directions or in one direction. Requirements and assumptions for one sample t-test. A one sample t-test should be used only when the data has been collected on one variable for a single population and there is no comparison being made between groups. For a valid one sample t-test analysis, the data values must be all of the following. First is independent. Values are not related to one another. The one sample t-test assumes that all errors in the data are independent. Term error refers to difference between each value and group mean. The result of a t-test only makes sense when the scatter is random, that whatever factors caused a value to be too high or too low affects only that one value. Prism is a graphical representation. It cannot test this assumption, but there are other graphical ways to explore data to verify this assumption. It should be a continuous measurement. A t-test is only appropriate to apply in situations where data represent variables that are continuous measurements. As they rely on calculations of a mean value, variables that are categorical should not be analyzed using a t-test. Third point is it should be obtained from a random sample of population. The result of a t-test should be based on random sample and only be generalized to a larger population from which samples were drawn. A fourth point that is required interpreting is it should be normally distributed in the population. That is, data should resemble a bell-shaped curve when plotted graphically. As with all the parametric hypothesis testing, the one sample t-test assumes that you have sampled your data from a population that follows a normal or Gaussian distribution curve. While this assumption is not as important with the larger samples, it is important with a small sample size, especially less than 10. If your data do not come from a Gaussian distribution, there are three options to accommodate this. One option is to transform the values to make the distribution more Gaussian, perhaps by transforming all values to their reciprocals or logarithms. Another choice is to use Wilcoxon signed rank non-parametric test instead of t-test. And the final option is to use t-test anyway, knowing that t-test is fairly robust to departure from a Gaussian distribution with large samples. Now, how to formulate a one sample t-test. Ideally, data from a one sample t-test should be collected and entered as a single column from which a mean value can be easily calculated. If data is entered on a table with multiple subcolumns, Prism requires one of the following choices to be selected to perform the analysis. Each subcolumn of data can also be analyzed separately. An average of the values in the columns across each row can be calculated, and if the analysis conducted on this new stack means or all the values in all columns can be treated as one sample of data, paying no attention to which row or column any values are in. The t ratio by dividing the difference between the actual and hypothetical mean by standard error of actual mean. The equation is written as follows, where x is the calculated mean, mu is the hypothetical mean, that is specified value. S is the standard deviation of the sample and n is the sample size. P-value. A p-value is computed based on the calculated t ratio and the number of degrees of freedom present, which equals sample size minus 1. The one sample t-test calculator assumes it is a two-tailed one sample t-test, meaning that you are testing for a difference in either direction from the specified value. How to interpret results of one sample t-test. As already discussed, a one sample t-test compares the mean of single column of numbers against a hypothetical mean. This hypothetical mean can be based upon a specific standard or other external prediction. The test produces a p-value which requires careful interpretation. The p-value answers this question if the data were sampled from a Gaussian population with the mean equals to hypothetical value you entered. This is the chance of randomly selecting n data points and finding a mean as far as or further from the hypothetical value as observed. If the p-value is large, usually defined to mean greater than 0.05, the data do not give any reason to conclude that the population mean differs from the designated value to which it has been compared. This is not the same as saying that true mean equals the hypothetical value, but rather states that there is no evidence of a difference. Thus, we cannot reject null hypothesis in this case. If the p-value is small, that is usually defined to mean less than or equal to 0.05, then it is unlikely that the discrepancy observed between the sample mean and hypothetical mean is due to coincidence that is arising from random sampling. There is evidence to reject the idea that the difference is coincidental and conclude instead that the population has a mean that is different from the hypothetical value to which it has been compared. The difference is statistically significant and the null hypothesis is therefore rejected. If null hypothesis is rejected, the question whether the difference is scientifically important still remains there. The confidence interval can be a useful tool in answering the question. 95% confidence interval for the difference between the actual and hypothetical mean is being reported. In interpreting these results, one can be 95% sure that this range includes the true difference. It requires scientific judgment to determine if this difference is truly meaningful. Now, when to use different types of t-tests? There are three different types of tests which can be used for hypothesis testing. One sample t-test, independent two-sample or unpaired t-test, and paired sample t-test. As described, one sample t-test should be used only when the data has been collected on one variable from a single population and there is no comparison being made between groups. It only applies when the mean value for data is intended to be compared to fixed and defined number. In most cases that is involving data analysis, however, there are multiple groups of data, either representing different populations being compared or the same population being compared at different times or conditions. For these situations, it is not appropriate to use a one sample t-test. Other types of t-tests are appropriate for these specific circumstances. The name of one sample t-test tells the general research designed for studies in which the statistic is related to test hypothesis. When we use one sample t-test, when we collect data on single sample drawn from a defined population, in this design, we have one group of subject, collect data on these subject and compare one sample statistics to the population parameter. Population parameter tells us what to expect if our sample came from that population. If our sample statistic is very different beyond what would be expecting from a sampling error, then a statistical test allows us to conclude that our sample came from a different population. Again, in one sample t-test, we are comparing the mean calculated on a single set of score to a known population. The paired t-test is a special case of one sample t-test. It tests the null hypothesis that the mean difference between the two measurements, such as the strength of the right arm minus the strength of left arm, is equal to 0. Now, there are multiple pros and cons of using these tests. First pro is that it is essential for generalization. The results that are achieved after the t-test are useful for concluding if they are actually correct and they can be applied to entire population. They are easy to interpret and it is very easy to interpret the output of independent samples. The output tells you how different the mean of one sample is from the mean of other group. A larger t-score indicates groups are different and a smaller t-score indicates that groups are similar. Robustness. It assumes that independent samples of two populations are normally distributed and have the same variance. It is easy to calculate it's easy to calculate data from two samples with the aid of a computer. And fifth is it is easy to gather data. A small number of subjects from independent t-test samples are required. Only one value from each subject is needed, and it requires the values of subject from only two samples on quantitative variables. Determine source data. T-test enables us to compare the average values of two data sets samples and determine whether the sample subjects come from the same population. It is easy to understand. The t-test formula for independent samples are easy to understand. They make it easy to know what is going on without needing much statistical training. It saves time since the small sample size is needed for calculation. It not only saves on money but saves on time required to collect and analyze large amount of data. There is control of individual differences. That t-test repeated measures design results in small effects since the amount of error from sample is very small. It provides necessary information. The test gives you all the information you need to know about the population. Every prong has different cons to every test and that are difficult to find subjects. Getting the subject for the sample data is very difficult and is also a very expensive part of research process. A carryover effect is when relying on paired sample t-tests, there are problems associated with repeating measures instead of differences between groups designed, and this leads to carryover effect. Small amounts of noise, although you might not worry about individual differences between the group data set, there is still an individual difference between the groups, and not every sample will react the same way, thus creating a small amount of noise. Environmental impact is that independent t-tests can help you determine the difference between sample groups but cannot help in controlling the effects of environment. Multiple comparisons t-tests cannot be used for multiple comparisons because they result in type 1 error. Reliability of data is that data collected violates the assumptions of t-test, then the output is unreliable. Now coming towards the recent updates. This article is recently published that gives the use of one sample t-test in real world. The work discusses how students' t-tests might still be validly applied to medical data that may violate the usual statistical assumptions. Here, the one sample t-test, which includes as a special case the paired comparison t-test, is treated in detail. Practical rules of thumbs are given along with their applications to various examples so that readers will easily be able to use them on their own datasets. Another article is published that is relaxing assumptions in the one sample t-test. This paper reviews that what is currently known about the behavior of the t statistics when one is no longer sampling from a normal distribution. Suppose Y is the badge of data on which t-test is performed. Briefly, then heavy-tailed components of Y gives a light-tailed t. Positive correlation amongst Y gives a heavy-tailed t, and positively skewed component of Y give a negatively skewed t. This emphasis is on understanding why one gets this type of behavior, although some numerical tables are presented to illustrate the conclusion. Now it's time for MCQs. First MCQ is in statistical hypothesis testing. A result has statistical significance when it is very unlikely to have occurred given the null hypothesis. A result is called statistically significant whenever option A, the null hypothesis is true. Option B, alternative hypothesis is true. Option C, the p-value is less or equal to significance level. And option D, p-value is larger than the significance level.
C.
Yes, option C is the right one. A value is statistically significant when p-value is less or equal to significance level. Second MCQ is a randomly selected sample of 1,000 college students was asked whether they had ever used the drug ecstasy. 16%, that is 16% or 0.16 of the 1,000 students surveyed said that they had which of the following statements about the number 0.16 is correct. Option A, it is a sample population. Option B, it is a population proportion. Option C, it is a margin of error. And option D, it is a randomly chosen number.
B. A.
Yes, option A is the right one. It is a sample proportion because already said 16% were surveyed. Third MCQ is statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of the data. Which of the following is not true about the standard error of a statistic? Option A is the standard error measures roughly the average difference between statistic and population parameter. Option B is the standard error is the estimated standard deviation of the sampling distribution for the statistic. Option C, that standard error can never be a negative number. And option D, standard error increases as the sample sizes increase. Option D is the
Beta.
right one. Fourth MCQ is the one sample t-test, also referred to as single sample t-test, is a statistical hypothesis test that is used to determine whether the mean calculated from a sample data collected from a single group is different from a designated value specified by the researcher. Now, what is true about a designated value? Option A, it is chosen from data set. Option B, it is an external value. Option B, C, it is a combination from data and external value. Option D, it is a mean value of data set. And option E, it is the mode of data set. Option B is the right one. It is an external value that is chosen on basis of some scientific reasons. Fifth MCQ is a one sample